Mathematical biology allows me to bring together two fields which I'm really passionate about. I'm trained as a mathematician and I love doing mathematics every day, but I also really want to know that the mathematics that I'm doing and the problems that I'm working on have an ultimate end goal and can be useful in society. When I first moved into this area, I really had to learn a new way of communicating, which was sort of equation-free and use lots of schematics and analogies so that I could explain the mathematics that I was doing, which is technical and complicated, to people that don't really need all of that complicated detail, but need to know the big picture ideas of what I'm doing. My group looks at different ways to treat certain medical conditions. So this extends from wound healing, where we have chronic wounds that don't heal by themselves and need treatment, but also looking at malaria and how drugs are used to treat malaria. The research questions that we set out to solve are usually how can we improve therapeutic procedures, so how can we get wounds to heal faster or better, and how can we treat malaria more effectively. So for example, in wound healing, I develop mechanistic models which look at how cells and chemicals interact with each other and the different processes that are going on that are driving cellular behavior. So that could be random motion of cells, it could be chemotaxis, which is when cells move towards gradients of something that they're interested in, and lots of other biological processes as well, such as cell division, cell death. This is a bit different to in the malaria case, where I'm looking at making predictive models for antimalarial resistance. We use the locations in space and time where data has been collected in a joint statistical framework to make predictions about where certain drugs can be used and where they can't. So we've already had some really interesting results come out of the antimalarial drug resistance work, where we've been able to find thresholds above which antimalarials won't work to prevent malaria during pregnancy, in infants and in children. And this is results that have been shared back with the World Health Organization. One of the things I'm really excited about for the future of mathematical biology is all the different fields of mathematics which have previously sort of sat outside the realm of what mathematical biology encompasses that are now being brought in. One of the great things about working at the University of Melbourne on the Parkville campus is that it has this biomedical precinct. So the School of Mathematics and Statistics is based on the Parkville campus, but surrounding that is the Doherty Institute, the Weehai Institute, lots of different medical research groups that are doing really good biological and medical research, which we're able to collaborate with on a day-to-day basis.